Hello friends, you're watching Syam Academy. First of all, thanks for being here in my YouTube channel Syam Academy. If you like our efforts to present our classes, please support us by liking this video and also subscribe to our channel. Refer to your friends about our channel Syam Academy. Thanks in advance. Let us go to our today's session. Under the concept of aromaticity, what are the main examples, what are the main concepts we have already covered in our earlier classes. So from the today onwards, we are going to discuss the most important questions which are asked in previous examinations like CSIR and GATE exam and TIFR, IIT JAM, mains and advanced. From all these examinations, I have collected the questions. So from these questions, I am going to discuss from the today onwards. So dear students, you don't miss the sessions from today onwards. Okay, so let's get started. This was the question asked in CSIR-NET June 2018. He has given these two compounds and he asked whether they are aromatic or anti-aromatic. So from the four given options, we have to choose one option. This is the compound from the cyclooctatetraene, where we know that cyclooctatetraene is generally a non-aromatic compound due to the inner hydrogens or cis hydrogens interaction. There is a steric hindrance between the hydrogen atoms in cyclooctatetraene, so that the compound is in turn structured into a tub shape. So we know that tub shape is a non-planar structure, so the compound is a non-aromatic compound. But if we remove two hydrogen atoms and this structure is formed here, so he asked indirectly to test our knowledge whether we have a fair idea in the aromaticity. This compound is a dication compound. So after removal of two hydrogens from two carbon atoms, so we got a dication. We know that. So after removal of hydrogens, ultimately the compound will get stability. It reduces its strain so that the compound is stable itself in a planar structure. So that this compound is planar and also there is a conjugation of pi electrons in the ring, 6 pi electrons. That is, it satisfying Huckel's rule. So it is an aromatic compound. The next compound. So this compound is similar to cycloheptatriene, and we know that cycloheptatriene is a non-aromatic compound, but cycloheptatrienyl cation is an aromatic compound, that we know. But the examiner asked indirectly, so he is simply substituting the CH2 group with an oxygen atom. So oxygen atom always have two electron pairs. Okay, so in this compound what happening is the one electron pair in the oxygen compound is participating the conjugated pi electron delocalization. From the Huckel's pi electron rule, the total number of pi electrons involving in the delocalization of pi electrons, 1, 2, 3 pi bonds and 2 electrons from the oxygen atom. Here you please note that the another electron pair on the oxygen atom not at all involved in the delocalization of electrons. It lies perpendicularly to the planar, so that only one electron pair is participating in the delocalization. So the total number of electrons involving in the delocalization are 8 electrons. If there are 8 electrons, then it is not at all satisfying Huckel's 4n plus 2 pi electron rule. So it is anti-aromatic compound. See here, 4 into 2 pi electrons, that is 8 pi electrons are involving in the delocalization of pi electrons. So this is simply 4n pi electron rule, whereas n equal to 2. So it is an anti-aromatic compound. In this example, if you see, there are 6 pi electrons involving in the delocalization of pi electrons. So it satisfying 4n plus 2 pi electron rule, where n equal to 1. So it is an aromatic compound. So from this idea, we can conclude that the compound A is an aromatic compound and the compound B is an anti-aromatic compound. I hope you understand. So let us go to another example. So which is also asked in the same year, same examination for the 4 marks. See here, Cyclooctatetraene is asked in the examination. So when we reacted this compound in presence of acids H plus, then a cation is formed. Okay. So this cation, we know that it is an aromatic compound because we have already discussed in our earlier classes, this compound is an homoaromatic compound because, so the carbon atom which is above the ring, it is not at all disturbing the delocalization of pi electrons in the ring, so that it is a compound of homoaromatic. He asked in the examination, he has given for the chemical shifts of various hydrogen atoms on the carbon atom. We should have a proper idea about the spatial arrangement of hydrogen atoms on the carbon atoms. So if we check the compound, then the hydrogen atoms on various carbon atoms are different, aligned in a different positions. Let us check. He has labeled the hydrogen atoms according to the numbers. Well, these two hydrogen atoms on this carbon atom is Hb and Ha, and also all the 7 hydrogen atoms on these 7 carbon atoms are H1, H2, H3, H4, H5, H6 and H7. In the examination, he has asked that to set the correct chemical shift values of the different hydrogen atoms on the different carbon atoms. Okay. So before going to discuss about this compound, we should have a fair idea about diamagnetic anisotropy. So in my previous class, I have discussed about the concept of diamagnetic anisotropy. So if you don't know the concept, then please refer my previous class. I will leave the link here, so you can check from here. From the concept of diamagnetic anisotropy, we know that this compound is an aromatic compound because, so if you see, there will be 3 pairs of pi electrons, 3 pi bonds in the ring. So 6 pi electrons. So these 6 pi electrons will involve in the delocalization of pi electrons, so that it satisfies Huckel's rule, 4n plus 2 pi electron rule, and where n equal to 1. 4n plus 2 pi electron rule where n equal to 1. If the compound is aromatic, then we know that there will be diamagnetic current. We have already discussed in our earlier class, that is diamagnetic anisotropy. There will be diamagnetic current. Okay, due to that current, if we place the compound in an external magnetic field, then what will happen? The 6 pi electrons in the ring will induce a magnetic field, and which is opposite direction to the external magnetic field, because it is an aromatic compound and it is a diamagnetic current. If the diamagnetic current is induced in the compound, you draw the induced magnetic field region in the compound, then these hydrogen atoms will come under the induced magnetic field region. Then according to their placement in the region, the chemical shift values will vary. If you see, at the edges, the induced magnetic field will be like this, from the top to bottom, and at the edges it will be in a circular form like this. Okay, then now you go for the chemical shift value. So in this diagram, clearly we can observe that from the hydrogen number 2 to from the hydrogen number 6, so these all hydrogen atoms are coming under the region of induced magnetic field. At this position, the induced magnetic field is parallel to the external magnetic field. So let us think this is external magnetic field direction B0. So we know that if the hydrogens are in the region of induced magnetic field, and if the induced magnetic field is parallel to the external magnetic field, then the chemical shift values of those hydrogens will be high. The effective magnetic field of those hydrogen atoms will be high, because the induced magnetic field and the external magnetic field both are added. For these hydrogen atoms, effective magnetic field B net equal to, okay, I hope you understand. These hydrogen atoms from the hydrogen number 2 to hydrogen number 6 are coming outside the ring, and they are in the region of induced magnetic field, and the induced magnetic field is parallel to the external magnetic field, so that the net effective magnetic field is high for those hydrogen atoms. If you see, these 5 hydrogen atoms has the value of 8.5 chemical shift value. You check in the options, chemical shift value is high. So here he has given that these chemical shift values. So among these we have to match the H226 to which chemical shift value. So it is matching with 8.5 because a high chemical shift value we observe. Okay. So let us check these two positions. Okay. So in the space, those two positions when comparing with these 5 hydrogen atoms are a bit away from the region, so that the net effective magnetic field also a little bit low when comparing with these 5 hydrogen atoms. So the chemical shift values of H1 and H7 and H1, so these two are also lying outside. So the value is around 6.4, less than these 5 hydrogen atoms, okay, due to the spatial arrangement. Okay, next. Now let us check these two hydrogen atoms chemical shift values. If you observe that Hb is oriented inside the ring, so there is a diamagnetic current inside the ring and it is in the region of induced magnetic field, but that induced magnetic field is opposite to the external magnetic field. I have already shown in the green lines. So the direction of induced magnetic field is in the downwards. Okay. So this Hb is coming under this region, so that which is opposite direction to the external magnetic field, so that the net magnetic field value will be low, so that the chemical shift value also will be low. So among those 4 options, Hb represents a low chemical shift value, that is minus 0.3. So that is the reason. Okay. Next, if you check the another hydrogen atom labeled Ha, which is oriented in the space in the opposite direction of the Hb, okay, but it is lying outside the ring and which is in the region of induced magnetic field at the direction which is parallel to the direction of external magnetic field, so that the net difference between Ha and Hb will be very high. So this Ha represents a chemical shift value around 5.1, okay, which is less than those all H1 to H7 hydrogen atoms due to the spatial arrangement above the ring and which is lying somewhat deshielded. So in that way we have to check the hydrogen chemical shift values in that compound and choosing the correct option. Okay. I hope you understand these two examples, so which were asked in the June 2018 CSIR-NET. So let us take another example. In this compound, only these pi bonds, pi electrons are involving in the delocalization of pi electrons, but the middle pi bond electrons are not at all involving in the delocalization of pi electrons. So that if you count the number of pi electrons in that ring, count 1, 2, 3, 4, 5, 6, 7, total 7 pi bonds. There indicates 14 pi electrons. That means if the n number is 3, then it's satisfying Huckel's rule, 4n plus 2 pi electrons. So this compound is satisfying Huckel's rule, and also it is a planar one, and there is a conjugated pi bonds, and also there is a huge possibility of delocalization of pi electrons. So it is an aromatic compound. Okay. So this example is also very important. So many times the examiner given this question in various exams including CSIR also. Okay. So like this one also very important. I hope you understand the most important questions asked in the previous examinations. So if you have doubts in this session, then please comment in the comment section. I will clear it. So in the next session, I will give you some more important questions asked in the CSIR and GATE exams as well, IIT JAM exams also. IIT JAM and JEE mains exams. Again, I am requesting you, if you like our efforts to present these classes, then don't forget to like our classes and also don't forget to subscribe. You see there is a subscribe button. So please click the subscribe button to subscribe, and also don't forget to press the bell icon. If you press the bell icon, then only you will get the notifications when I upload the videos in our channel. Okay friends, thank you. Peace out.